Good morning, everybody. It's a beautiful morning here in New York City, so no better time to do an algorithm, right? This one is this is a really good algorithm to study, and I got this question. I got part of this question in an actual interview for a pretty big tech company. So this is not the entire, interviews algorithm, which is a little more original to theirs, but this was a big part of the larger thing, so I thought it'd be fun to kind of explain. The idea is that given two arrays of arbitrary lengths, return a single array of sorted elements. All elements are numbers, positive and negative, and I just kind of designed this on codewars, so you can get the link to it in the description. But these instructions I need to update. One constraint is that both arrays are already sorted, so that's a guarantee for us. So keeping that in mind, when you get extra information like that, like when arrays are already sorted, it usually hints at something. It usually hints that you can perform the algorithm in a fast way or a faster way than if you didn't have that extra piece of information. So what does it mean to have two sorted arrays? We have, 1, 3. Let's just take, this first example that I have here actually. We have the arrays 2, 4, 6, and 1, 4, and 5. So one thing, if they are sorted from least to greatest, which they are, and we're merging it into sorted arrays, we kind of know that all the smaller numbers are going to be at the beginning of both of these arrays. We don't know which element in the beginning of these is smaller. It could be the first one here, it could be the first one here, but we do know that at the very least, the first element is probably going to be somewhere in the beginning of these arrays. So we can look over here and basically compare these two first elements. This one is the smallest out of this independent set, and this one is the smallest out of this independent set. So whichever one of these are the smallest, together, that's the first element that we want, right? So we compare the element here, which is 2, the element here, which is 1. 1 is obviously smallest, so we can kind of, remove that and make a list here. Now we have the second smallest element here, which may still be smaller than this one because they're independent, but it might not. So we want to kind of, compare this again, see, this was still larger the first time around. This time around, it's not larger, it's smaller than this one here. And since we know that these elements will only become greater than 4 over here, we know that this will be smaller than the element here and every subsequent element. So we take, this 2 out, and then we put it here. Now we're comparing two numbers of equal length. Let's just say the first one that we get first, we sort. So we say that one gets priority. Now we're comparing 6 to 4, and again, if 4 is smaller than the element here, it's going to be smaller than every single element going forward because these arrays are sorted. So this 4 wins out, and that takes care of the two values being equal next to each other. And now we compare, 5 and 6. 5 is smaller than 6. And now we have a situation where we have one element remaining and no more elements there. Once this happens, we're just going to be able to take the rest of these elements and put them to the end of this array, since, as I've been saying like a broken record, they are sorted. We take here, we take here. So that's kind of the human way of doing it. Did you notice a specific pattern when we were going through that? We are always kind of taking the first element in an array, and we're either pushing that element into the result or we are waiting for that element to become the smallest one. So one thing we can think about is having two counters, which is how we will implement this algorithm. But we're comparing here and we're comparing here. Once this one is smaller, we are moving that over. We're going to increment this counter. This one stays where it is. Then this one is larger, this one's smaller, we'll increment this counter. Then they're both the same, we'll just increment this one like we gave priority to the first one before. Then this one's smaller, we increment this counter. Then this one is smaller, we increment this again. It basically goes to, you know, undefined. And this one stays here, this one's larger, this one gets incremented, and now we are out of both of these arrays. All right, so let's try kind of doing this in a, you know, in a bit of a brute force kind of way. Not a brute force kind of way, actually. Let's get a little bit into it. If we think about this in terms of time complexity, you know, we had these elements of, you know, an array of 3 elements each. So we have to go through, we have to compare each element. I should say it this way. Each element out of both arrays are going to be pushed into a result array. So the result array is going to contain the combined total number of elements from array A and array B. In other words, you know, the time complexity is going to be basically n of A plus B. That's how many times we have to sort through these arrays. So let's jump into some code and explain exactly what that means. A lot of times when we do, you know, iterations, we would do a for loop. So we can say for let I equals 0, and now we already run into a problem. Which length in the array are we comparing it to? Well, you could say we want to compare it to the largest array, right? We'll do something fun here. We'll just say let large equals math.max. This will just return the larger value. So whichever length is larger, it will return that. And let's say I is less than large. We don't need to do dot length here since we've already done dot length up here. It just returns the actual number. So we compare it to that number representing the larger array length. And then we increment. And let's just say, you know, if array 1 of I is less than array 2 of I, we want to, first of all, declare result up here. We want to do result.push array 1 of I, because that's, you know, the smallest one. Else, let's say result.push array 2 of I. Now, if you've done a lot of things with arrays, you're probably already seeing what some of the problem is here. Let's console log the result. Return result. Okay, great. So if we run this, see we get a good amount of errors. Some of them actually do pass, others do not. So, you know, the arrays of equal lengths are kind of working in weird ways, but arrays of arbitrary lengths do not seem to work. You see we're getting undefined here. And if we're looking at this, it's because it basically took, you know, these 2 arrays here, incremented 1, 2, 3, and then started comparing, you know, I should say incremented 0, 1, 2, because these are 0 index. Then it compares index 4 with index 4 here because, again, we're comparing array of I and array of I. The index stays the same. There is no indexes that's like 4 and 5 over here. So now we're getting these undefined things. So things aren't working too well. Remember how I put before those 2 little kind of pointers on each arrays. We want these arrays to be tracked individually. only when we are pushing the smallest value of an array do we want to move that, move those elements forward, that pointer forward. So these both start at the beginning of the arrays because they are sorted, like I've been saying. And as we just did, when we were typing it out in the human way, we started at the beginning of both of them. So we want to have two little pointers that keeps track of each of these arrays. So let's say let pointer 1 equal 0, let pointer 2 equal 0. So these pointers are going to start at the beginning of these arrays. This is what we'll be using to index each array. Now in here we can, refactor a bit. Let's actually full screen this, make it a little nicer, make it a little bigger for you. So in here, array 1, the index in array 1, the element there is the smallest. So we push that to the result, and then we want to increment that pointer. So let's start by adding pointer 1 and pointer 2. So if the element that we are currently on in this array is smaller, we'll push where that specific array is, and then we want to increment that. We could do something in the same way we did that initial example where we take the element out of that array and actually mutate that array so that the next element gets shifted downwards. That would essentially mean we're always doing something like array 0 of array 0. But I don't want to, it's a little more functional, which is pretty good practice these days to keep things from being mutated. So instead of mutating these arrays, we're just kind of, putting a little bookmark on each array to keep track of how far along we are in it. So we move, that bookmark a little further up. And then if this is not true, then we can assume the element at pointer 2 in the second array is smaller. So we'll push array 2 of pointer 2. And great. And of course there's, one other thing. We have those undefineds, right? We want to handle that arbitrary length. So we'll first set it up in an if statement, then I'll show you a more clever way to comparing arrays of arbitrary lengths. We, can say if array 1 of pointer 1 is equal to undefined. And again, the reason I'm checking for that is because once we get to the final element in here, say this is an array, say ARR is a length of 3 with the index at 2. Once we get to this 2 here and push that, we're going to increment this one more time so the index is at 3, which is, in the undefined realm. So the pattern that denotes that we are done with a specific array is that array of pointer 1 is undefined. So if we are undefined here, we just want to add the next element in the other array. So we can just say array of 2, or we can just push array of 2 pointer 2. So we can do result.push. Yep, that looks good. And then pointer 2 plus plus. And then we're going to say continue. So continue cuts off this stuff here. If we have an array that's out of values, we don't need to be comparing anymore, and then we'll do the same thing with the inverse. Array of 2, pointer 2 equal to undefined. Just grab the next value. Array of 1, pointer 1, and pointer 1 plus plus. Okay, so we've accounted for missing values, we've accounted for comparing 2 values each. Let's try to see where we are now. So we got some passing, we got some failing. This one is really interesting. Let's come back to that in a second. But one point I really want to make is, okay, well, so for this one we have result 3, 3, 3. So it looks like this 3 just keeps getting pushed and we're not incrementing a pointer. And of course it's because I made a mistake here. I'm incrementing the wrong pointer. If we're at pointer 2 and pushing those values, we are incrementing, the elements in B, basically. I'm basically, taking an element, pushing it, but I'm not going forward in it. I'm just going to this other one over here and moving that bookmark over. I want to kind of keep track of where both of these are. So if I do that, we should see a little more results. Oh, and I also want to, wait. If pointer, I did the wrong thing. So I do want to increment that there, but I should be looking down here. So the actual thing was I did not increment pointer 2 at all. We pushed that smallest value, but then we keep looking at that smallest value. So we're just going to keep repeating, repeatedly pushing it. Pointer 2 plus plus. Okay, trying one more time. Great, so now we're doing a lot better. We actually are doing much better than I thought we would be doing. But we have some weird things going on here for sure. Oh, and that's probably because I didn't put continue over here. Okay, cool. We're now passing everyone except for one, which is this one here. It's logging 0 each time. So something seems to be, do you see these things with pointers? I did the same thing in the interview looking at this stuff, is that keeping track of these pointers, especially copying and pasting, can be very difficult. You want to really look at some of this stuff. Okay, so keeping this. Waiting to execute. Taking a while. Sometimes the server hangs a bit. Okay, cool. So doing a little bit better. Oh, I actually wanted this to be pointer 2 and this to be pointer 1. Right? Because we're taking the opposite one, the one that has values, not the one that doesn't have values. Cool. All of these tests passed. But I should really probably make my tests a little more robust because this is not the largest foolproof answer. So let's make this a little bit, a little bit better. If, for example, actually this works pretty well. But what I really want to do is I want to go through this, just like definitively go through this loop a plus b times. Actually, putting that over, I wonder if, would the max be the same? If I wanted to go over this a plus b times, these combined lengths, I would basically, instead of do math.max, I would do array 1 of length plus array 2 of length. Because if I'm comparing, an array of 1, actually kind of can't believe I passed all those tests doing it the way I did before. If I did array of 1 and array of 2, and I, compared it each time, I would compare, that's one compare, right? that's 2 compares, and that's 3 compares. So it's 3 compares total, but math.max would only give me, 2 compares. So that potentially might not work out in the way we really want it to. So if I add these two together, that length is 1, that length is 2, that gets, the sum of them both, which is all the amount of compares that we really want to be doing. You can do that. And the other thing we can do here is, this is perfectly fine, but there's kind of a fun way to, when comparing for greater than or less than, there's a fun way to always kind of force a default, and that's using the number infinity. That is a number in JavaScript. And what infinity really does is basically, I don't know exactly how it does all the arithmetic. If you multiply by it, I think it just does infinity. If you add numbers to it, it stays infinity. But if you compare something is less than infinity, that will always be true. And if you compare something is greater than infinity, that will always be false. So you can kind of force conditionals very nicely with this. So I'm actually going to say we're going to get rid of these, and I'm going to initialize some values now. So array1 of value is basically going to be our array1 pointer. I'm just going to save it there. But if this is undefined, then we are going to make it infinity. That way, the opposing value will always be less than and will always be selected. So I can say if this equals undefined, it will return infinity. If not, we'll return, again, the actual number. So again, this is a ternary operator. This basically compares this. It's a condensed if-else statement. If this is true, it resolves to this. Otherwise, it resolves to this. So basically, it will default to infinity if there is no value. And we'll do the same thing for array val2. 0.22. And great, so with those things in mind, this if-else statement will also handle empty arrays. This handles all the different types of logic we actually have. Let's attempt that and make sure it's still correct. We got one thing wrong. What did we get wrong here? We got undefined. That seems a little bit strange. So we got undefined after the 10 here, right? We were doing great up until array 2. The array 2 value is now undefined. We've incremented past here, and we're supposed to be just adding these remaining 2. So what happened there? We have, of course, one thing I didn't do, back to refactoring. Since I'm using these vals now, I need to replace all these, array 1 pointer, array 2 pointer with the vals. So array 1 val, array 2 val, that is array 1 val. We keep the actual pointer the same though, because it's still that pointer that's keeping track of where we are on these arrays, and that pointer is being used in the next pass of these loops to grab the next value over, or the same value if we're still waiting for that to be the smaller one. And then array 2, so we'll push array 2 val. Okay, I think I got all my ducks in a row, ducks being variables. Let's close that, and let's attempt it again. Whoa! Something went crazy here. So we're doing, so weird things are happening. Let's take a look at this one here. Okay, we're getting closer. is the same pattern as before. We got up to 10 and these last two values weren't working correctly, but this time it's pushing undefined, it seems. So again, we have array 2. Oh, see this here? More refactoring problems. That should be array 2 of pointer 2. That's correct there, that's correct there. Array 2 val, array 2 val, array 1 val. Yeah. I would actually like doing this again just off the top of my head right now. I might make, array 1, I just might call it like left. So it's the array that's over on the left, and then right for the array that's over on the right, because these are very similar variables, and as you can see, it's very easy to get them confused. But once everything's named correctly, we pass. Woohoo! That's great. Hope this was really helpful. Let me know in the comments if you have any questions or if you want to see other types of algorithms. Sorting, two arrays that are also sorted really allows you to write some, very elegant code. All of that is done in just a few lines of code, really, not without the console log being there. And, refactoring, all that good stuff. Blank lines, you get the idea. Hope that was great. Enjoy the rest of your day.